Everybody's got a label then, right? All right, let me ask you guys, who's played 21 before? The card game, all right? Also known as what? Okay. What are the rules for this game? So, you want to get as close to 21 or dead on 21, right? The one closest to 21, whoever has 21 wins, correct? If you go over, you lose. All right. We also know that, so we want to get to at least, so let's see, user, it's got to be equal to or less than 21, correct? Just some pseudocode, nothing too elaborate. What about values of the cards? Like face cards, how much are they worth? Face cards are worth 10s. What about ace? 1 or 11. And then number cards are equal to their equivalent, right? We good about that? Now you guys are probably wondering what the hell does this have to do with networking? Well, last week we were talking about the OSI model, correct? And we said there are 7 layers in the OSI model. We said that there's going to be the application, the presentation. Now from now on, in the interest of saving time, I'll probably just abbreviate these or just go off of their numbers. This is layer 7, 6, 5 is the session, right? 4, transport. 3, network. 2, data link. And 1, the physical. And in last week's exercises or lectures, I was trying to drill to you what exactly happens when we go down from the layer 7 and work our way down the stack. And we call this the encapsulation process, right? And I said each and every one of these layers are going to be assigned protocols. And I said protocols are a set of rules that govern the way we're going to communicate or use the network, correct? Chapter 3, that's this week's material. We're going to be learning these upper 3 layers, how they interface with the user and they interface with the network to get the message across from end device to end device. In today's demonstration, I'm going to be using a card game to illustrate this. The people that are going to be playing this card game is going to be the people that sit on the very far end of each row. So for instance, it's going to be Brent, Michael, and the other Michael. Is that right? What about the people in the middle? You guys are going to be my intermediary devices. You guys are going to relay the messages from place to place to place. Now you have to listen to these names again. I have Michael in the back, I have Michael in the front, and then I have Brent in the second row. I could be dealing these cards all over the place from any different person, but they need to get to their attended person. You guys are the intermediaries, the mediums, the devices that connect the dealer, me, the server, and my clients, the end devices. Well, it looks like we got a new end device coming in. So, all right, so now I have to remember, gee, I had Michael's name. Let's see. It's a different seat. I'm away from my attendance sheet. Can you help me out, Gavin? Derek? Thank you. Thank you. All right, so now we have Derek, which is very helpful because we had a conflict in names, correct? So we have a Derek in the back row, we have a Brent, and we have a Michael up front. Okay, folks? You want to pay attention to this. This is me establishing the session. I'm trying to open up dialogues between Derek, Brent, and Michael. All right? I need to establish roles so you guys know how we're going to play this game, how the communication process is going to happen. These are our protocols. So here I am listening them out to you. Protocol 1. I have this deck of cards. I need to deliver it. So I'm going to be following the rules of blackjack. That's the application. That's the software that we're using to play. Presentation. You guys are familiar with these, right? Yes. They haven't always looked this way. In fact, in the old days, when it came to a number card, they wouldn't have a number on there. They would just have the number symbols. We've gotten lazy over time. Okay? Session. I'm doing that right now. I'm making sure that Brett, Michael, and Derek are aware that you guys are playing me in 21. If you guys have money, now's the time to get it out. Otherwise, let's get somebody else that can play. All right? Now, what about the transport layer? The transport layer, I said, broke the data up into segments. Right? And why did we do that? Because we want to make the medium as efficient as possible. We want to use that medium. We also don't want to get it bogged down, and I'm not going to deliver all 52 cards to a person, correct? I want to try to get this multiplexing. And so what I'm going to try to do is try to deal out and shuffle. I mean, after all, when you start dealing out cards, it's one for one person, then one to the next person, and one to the next person after that, correct? You don't give the first person 2 cards. Then you go to the next person and give them 2 cards, correct? Why do we do it that way? Why do we go one after another after another?
Just in case they're not shuffled. So the delta.
That could be the reason. The other thing that could help is that while I'm passing the cards out, it gives each person a chance to look at their card. Do we deal out the first card face down and the second card face up? So in the meantime, the person can look at that card and be like, okay, I know what I need. It gives them time to process, correct? They should all be looking at that first card and making a whole bunch of decisions off that first card. Some of the decisions are going to be, well, am I out of 10? I'm looking for an ace. If I have an ace, I'm not going to bother looking at my card, and I'm just going to try to play this off. Should I double down? All of which are determined by the first card. Why do we deal the first card face down and the rest of the cards face up?
So the rest of the people don't know. That's
Folks, it's all about probability. You know there's 4 cards for everything, correct? There's 4 queens, there's 4 kings, there's 4 jacks, there's 4 ace, so on and so forth. If there's 4 people playing and everybody received an ace, what does that mean about the rest of the deck? There's no more ace to be played. But see, you don't know that. What are the chances of 4 aces being dealt in a row?
Slim.
Do you see the probability? Do you see the rules that we play? So this is what we're going to follow. We're trying to take some of this, the way we play cards, and apply it to the way we communicate using networks. So we're at the transport layer, and I'm going to segment this. I'm going to divvy this up evenly, but I'm going to need to have some kind of way of transporting that. And that way of transporting it is going to be in an envelope. And the only people that get to see this envelope, if I can pull this out, are the end devices, the server and the clients. For today's class, this envelope is going to be representing a segment. And isn't that what we call the PDU for the transport layer? And folks, what do you put on envelopes? Addresses, names. Yeah. Why? Those are protocols that we have to follow by the US government. But folks, we can use an envelope for a whole bunch of different reasons. And we can address it the way we want to address it. We are establishing rules. And this happens all the time. I gave you 2 examples of protocols when it came to the transport layer. TCP and UDP. We can add more protocols to this. We're going to make a new one today. This is not an official one, but we are going to call it BJP. Blackjack protocol. Is that okay, guys? And what have we learned about this? This protocol has to play nicely with the layers above and the layers below, correct? All right, so the way this is going to work is I'm going to use a source. I'm going to use a destination. I'm not going to leave it. Is it going to be a left hand or a right hand? Actually, we can put another one on here. We can even find playing blackjack is our address. On to the next layer. What do we call the PDU for? Envelopes come in all different shapes and sizes, folks. Same thing about PDUs. This little orange or gold envelope that you see right now, and I sort of followed the post office locations for addresses just to make a correlation with you. This is going to be considered our packet. This is where names come in. Addresses. We call these local addresses, and the protocol we used was called IP address, right? Or sorry, just IP, the Internet Protocol. Here I'm going to make a new protocol. I'm going to call it SNP, Simple Name Protocol. And I'm just going to keep it simple. It's going to be your first name, and that's it. This is why I had a conflict with Michael. Remember what we said about this layer? No two devices on the same network can have the same address, right? In this case, this classroom's our local area network. And I have two Michaels. Now, they're both spelled differently, so that would be kosher. But listen to how we hear that. And I could be pronouncing Michael in the back incorrectly. Michael, is it M-Y-C-A-L? And the Michael up front, is it M-I-C-H-A-E-L? It's funny how humans work. The way we pronounce things and the way we hear it. If I were to write those things down, then you guys could see the difference. And you can identify them. And that's all this layer is about. It's about end-to-end delivery. I have Michael, Brett, and Derek. These are the names I'm going to put in there. Now, in the interest of saving time, I'm just going to be using the letter M, B, and D, as well as N, right? Because I'm the server, they're the clients. Moving on. We had the data link layer. What was happening here? What was the sole responsibility? If you watched the PowerPoint, I told you this, said it in lecture last week. It's a frame. It's going to produce a frame. Yep, that's the PDU. And how helpful is this frame? Because this is where you guys fall in today. Most of you. This is going to be for local delivery. And one example would be like the Ethernet. In fact, since there's so many different standards, we usually call that network standard protocols, NSPs. This is where things get a little bit interesting because I have two types of addressing going on. I have a logical addressing and I have a physical address. A physical address would be like where you guys are sitting in this classroom. A seat. This is row 1, seat 1. So Eric, spelled differently, what would be your physical address? Correct. Tom, what would yours be? You see how he had to skip one because we don't have somebody here, right? And so, Keelan, is that right? Kellen, sorry.
Row 2, C3.
You get it. Once again, no two devices on the same network can have the same physical address. We were running out of seats at the beginning of this class, and I don't think you guys would like sitting on top of each other's laps, right? So we're going to create our own protocol, and we'll call this, I don't know. I got to be careful because sometimes you can just spell out letters that spell words, if you will. Oops, I got to put this in red. ASP. I was going to put another S in there, but we'll leave that out. So that would be like address seat protocol. Is that okay, guys? And remember, this is a physical protocol. This is where everybody actually everybody's involved in this. You guys will, as we pass these envelopes, and the envelope that looks like that is going to be this right here. In the white, you guys will be writing out. If I'm creating this frame and I'm passing it out, I'll just write oh, I don't know, 0, R0, seat 0. Is that okay? That's me. I don't have a seat. I don't have a row. Following the same rules. Listen to the protocol. I'm saying you need to put an R. Let's put a colon, then the number, then a comma, then an S, then a colon, then a number. In fact, let me replace that so they're number simple so you guys don't write down zeros. And that's what protocols do. Remember how an IP address is formatted. A number followed by a what?
Letter.
A dot. Right? IP addresses? It's a number followed by a dot followed by a number followed by a dot, right? There are 4 numbers. They're separated by 3 dots. And what's the range of those numbers?
0 to 255.
Yeah, because that's IPv4. That's what's declared in those protocols. So as I'm writing my protocols, I'm telling you guys what to write in there. Source, left, right, or table. That would be for the blackjack protocol. Then what about this one? I said addressing is simply going to be names. I'm using the first letter of the first name, right? M, B, D. We good about that? All right, let's see this in action. Here I am. I'm going to send out the very first card on the top of my deck, and it's going to be sent to Brett. Now, wait a minute. I got to follow the rules of blackjack. And what's the dealer's left? Left to right? Yep, so dealer's left, which would be Michael, correct? Out of these 3 envelopes, which one am I going to use first? Am I going to use the skinny white one, the gold orange one, or the nice bubble wrap one?
The bubble wrap.
Where do I start? I'm up here at the application layer. Remember, I had to go grab the data, and we're playing blackjack. This is the presentation of my data, right? The cards. And so I grabbed it. I'm going to put it in my white envelope. My white envelope represents what we would call a segment in the real world, but it's going to be my blackjack protocol. What am I going to do with that? What am I going to put on here? According to my protocol, I have to have a source and destination port address, if you will, right? So I'm a right-hander. Oh, where did I leave mine? There it is. And I'm going to put on here source came to the left hand, and I'm going to deal it not to the person, but rather to the table, correct? What happens next? Where does this go? This has to come down the layers. So we're right here at the transport layer, and we're going to go into what? So I got to use which envelope? One on my left hand or the one on my right hand? So I put this inside. This is encapsulating. Do you notice I'm not changing the card itself? I put the card inside an envelope. I labeled the envelope. This is the header. I kept it simple. I just asked for a source and a destination. I'm going to put it inside another envelope. It means I'm taking what was already encapsulating it, and I'm going to encapsulate it again. I take my segment, and I make it a packet. What am I going to put on this packet? According to the protocol, I got to use SNP, right? And that says source and destination. So let's just say that this is the source, and this is the destination. Okay, guys? Source is me. Destination is Michael. What do I do with this now? This packet. Put it inside another envelope. Now they tell you, before you open up any package, you always want to examine the outside of the envelope to see if it's damaged. Why do they tell you that? Once you open it up, folks, how do they know you didn't damage it and you want your money back? Correct? So, last week I told you the frame has 2 parts, a header and a trailer. The trailer is used for what? Error detection. As you guys are passing this back from place to place to place, make sure that the labels are marked right. Make sure that nothing's damaged with it before you proceed. If something's wrong with it, throw it away. Okay? That's what happens in networking. What am I going to write in my source? Protocol is R colon then a number, right? So R